Alright, so let's just keep plugging along on this learning packet and get this next sheet done, next problem done. So we launch a football at an angle of 25 degrees and it flies through the air, and this problem's a little bit different because we're not actually looking at the whole trip, so we can't use our formulas for range, hang time, and height. Instead, we have to kind of be a little more specific because we are looking at part of the distance where x is 35 meters. And we start off from x naught equals 0. Our initial speed is 30 meters per second. So let's actually go ahead and solve for what they want us to. First, we want to know how much time passes before the ball goes 35 meters. So that's going to be x equals v naught xt plus x naught. And that means 35 equals 30 times, ooh, you know what? I wanted to plug this in, but I want to make sure that people are sort of clear on this. 35 equals v naught x times t plus x naught, which is 0. Now I want to be clear on something. This v naught x, you actually have to be careful how you calculate it. V naught x is going to actually equal v naught times the cosine of that angle right there. So that's going to be 30 times the cosine of 25. So we actually need to go ahead and calculate that right now. So we take 30 times the cosine of 25, and we're going to end up getting 27.2 times for v naught x. And then we solve for the time. When we isolate time, we're going to end up getting 1.29 seconds. Awesome. Now for part B, we want to know the height of the ball after 0.5 seconds. So we're starting at 2 meters high. That's what they tell us here. So 2 meters above the ground. So let's go ahead and do that. So we're going to have Vy squared. Actually, I don't know if that's the right formula because we actually have a time here, so I want to make sure I get that right. So I'm going to use actually a different formula. The formula I'm going to use is y equals negative 1/2 gt squared plus v naught yt plus y naught. And that's going to be y equals negative 1/2 times 9.8 times 0.5 squared plus, here for Vy, once again I need to be careful. That's going to be here 30 times the sine of 25. So that's going to be 30 sine of 25 times 0.5. plus 0. That's how we're going to end up getting the height. So I'm going to go ahead and put that in my calculator. And when I run the calculation, I end up getting 5.74 meters. I hope I did that right. I know I set it up right. I hope the number is right. So you'll have to check that yourself. Now, number 17, we have a baseball being thrown. So let's actually just go on to number 17. Go ahead and delete this out. And this too. So we've got a baseball being thrown. Let's just set this up. So the baseball is being thrown with a horizontal component of velocity of 25 meters per second. And after 2 seconds, the ball is 40 meters above the ground. So y is 40 at time equals 2. And we want to know the horizontal distance that has traveled this time. And a couple of other things. So let's try to figure this out. So we know that the ball is 40 meters above the ground after 2 seconds. and we have the horizontal component of the velocity of 25 meters per second. So first, the horizontal distances traveled is x equals v naught xt plus x naught. And so that means we have 40 equals 25 times 2 plus... Whoops, see, I made the classic mistake. We don't put in 40. That's the y distance. So this is x equals 25 times 2 plus 0. So x is going to be 50 meters. Now, we want to calculate its initial vertical component of velocity. So we know that after 2 seconds, the ball is 2 meters high. So let's just try to figure this initial component of velocity. So for part B, I'm going to say y equals negative 1/2 times 9.8 times 2 squared plus v naught t in the y direction times t plus 0. And of course y we know is equal to 40. So we're going to end up getting 40 equals negative 4.9 times 4 plus v naught y times 2. And finally, when we simplify, we're going to get 40 plus 4.9 times 4 equals v naught y. If we divide this whole thing by 2, so we get 20 plus 9.8 equals v naught y. So I'm getting v naught y equals 29.8 meters per second. So let's go ahead then and let's see what does the next part say. It says we want to get the initial angle that we're at. So that's theta is going to be inverse tangent of v naught y over v naught x, which is going to be 29.8 divided by 25. So we're going to end up getting theta equals 29.8 divided by 25. When we take the inverse tangent of that, we're going to end up getting 50 degrees. Nice. Now we want to know if the ball's on its way up or on its way down. Well, if we've got an initial speed of 29.8 meters per second, let's see how long it takes us to stop. So Vy equals V naught y plus V naught yt. Sorry, Vy. Let's just, we'll fix this. Whoops, mistake. Let's get Vy equals, let's just go ahead. So we got Vy equals negative gt plus V naught y. And for negative V naught, so for V naught y, we're going to put 29.8. And for Vy, well, at the top, we want to see how long it takes to get to the top. It's going to be 0. So let's go ahead and solve. So g is 9.8 here. So let's see. We're going to get here, when we rearrange this for part D, when we do all this math, we're going to get negative 29.8 divided by negative 9.8. That's going to be the time. So 29.8 divided by 9.8. That's 3.04 seconds. So if it takes us 3.04 seconds to get to the top, and we're only at 2 seconds up, this must mean that in part D, we are on our way up. Excellent. Now, let's go ahead and take a look at the next problem. That's good. Now here, we got a home run that lands, blah, blah, blah. This is clearly a very dated worksheet. So, yeah, sorry. Clearly, yeah, years old. So here we go. We got a home run that's hit. I can't even bring myself to say the name. All right, so we got a home run that's hit 125 meters. Let's see. So here we go. We start here, 125 meters. That's x. We have a height of 30 meters. And we fired at an angle of 45 degrees. And now we want to calculate how long the ball was in the air. So So it lands in the stands, and it's 125 meters. So here we go. Let's see what we can do with this. So let's just say that x equals v naught xt plus 0. So we're going to have 125 equals v naught xt. Now, we also have a couple of equations we can use here. So we have v naught y squared. So vy squared equals v naught y squared plus 2 times negative g times y minus y naught, which is going to be 30 minus 0. And we don't know that vy squared is 0. We definitely know that we don't know if either of these is 0. We don't know that if it landed with vy equals 0. We can't say that. So we've got to kind of figure this out a little more carefully. So let's see. We got vy equals v naught y minus gt. And finally, we have here y equals negative 1/2 gt squared plus v naught yt plus y naught. Interesting. So we've got a lot of unknowns here. So I'm going to actually have to come back to this one a little bit later. So I might do this one in a separate video. There we go. Here. A golfer can drive a ball with an initial speed of 40 meters per second. The team green is over 100 meters, but on the same level, what angles would the ball be driven? Let's see. So from 19. This is actually our range equations. We're going to have x equals v naught squared sine of 2 theta over g. So we have 100 equals 40 squared times the sine of 2 theta divided by 9.8. So we're going to actually end up getting 9800 divided by 40 squared equals the sine of 2 theta. So let's make sure. No, that's 980 divided by 40 squared equals sine of 2 theta. So we're going to actually get that sine there. Let's go ahead and do that. So we actually end up getting 2 theta equals 37.77 degrees. So that means theta is going to end up equaling 18.88 degrees. That's a good one. All right. So now, here we go. Wow, this is a really good one. I really like number 20.